Okay, we're set up in the mill to do these drilled and tapped, drilled and reamed, and counterbore holes for the crank pin, and I'm going to use a coordinate system to position these. I've got quite a tight nest. I'll bring the camera around a little bit. I've got a quite a tight nest of holes in here. So I've got the mounting holes that go onto the worm wheel, and I've got the mounting holes that have the crank pin. So rather than coming at angular, using angles to work out positioning, we've gone with the coordinate system. So just a little bit different, but it just allows me to get all the relationships between all these holes the same, or so that everything clears. So I've got that set up over there, so we'll head on over to the mill, and first thing we'll start doing is we'll spot our holes, get those done, then we'll drill through with our tapping size for an M8, then we'll drill through with an undersized drill for the reaming, then we'll ream M10, then we'll set up our boring and facing head, and we'll counter bore that out. So we'll see how that goes, then we'll come across and we'll do the through holes and the counter bored holes for the mounting screws. So that's the plan, and we'll see how we go. I guess I really didn't have to counter bore these. These could have been just left flat on the disc. Just that I want to have a try with my boring and facing cutter, my boring and facing head. I've never done them before, so not at home anyway. But yeah, I just want to try it out. We'll set up the stops on it and see if we can come out to a set diameter and see how that works out. Alright guys, we'll get on over to the mill and we'll get started. Alright, so I've left the job in this 200mm chuck. I've just taken that straight off the lathe, and I've put parallels underneath it just to pack it up off the table, and just a couple of clamping fingers. Alright, we'll do the top one first. So the offset on that one there is 33. I've already zeroed this up and centered. So I'll come off 33mm. So I just spotted these. I actually want to scribe the 27mm diameter counterbore hole on it, just as a reference. Let you know where we're going. So I'll just mark that up in blue, and then I'll get those lines scribed on. I was going to go 22.7 for this first one. The idea is that we don't want to break through. More critical on this one here, that's on the outer edge. I just want to make sure that I keep the marking out intact, so I'll keep using the tapping magic. It's just likely to take it off from the CRC. Right, we'll come up 33 millimeters. And come across to our centre. If I'm going to break through with any of them, this one's going to be it. And no breaking through. Right, we'll go with our reaming drill next. Now this is 9.5 mil. I should be going a little bit larger than that. I'll see how this goes anyway. You know, a 9.8 or something like that would have been far better. So we're going to go just a tad over 10 millimeters on this one. So we'll go about 10.5, I reckon. So it's 10.5 for that one. Drop back down 4.5 past our centre. And 17.5 off. Right, we'll set up for reaming now. We'll see how this goes. nice one. Across 33. Across. Alright, all done. Right, we'll get set up for the counter boring, but what I might do first is I'll just give us a heel to start with. I'll sink down an M mill, just open that down to 1mm, and then we can just clean that out with the boring and facing head, and we'll see how that goes. Alright, sorry guys, I forgot to turn the camera on. So I've already done one, and we'll come out and we'll do this one. Alright, this will get rid of a lot of the meat anyway. So coming down about 0.9, counterbore size is 0.8 finish, so just gives us a little bit to clean up on the base. Let's come across for the last one. Alright, that's taken a lot of that meat out for that counterbore, so next job is we'll set up with our facing head, and we'll take that out to diameter and just a very light lick on the bottom. Alright, those holes that I have scribed, those circles I've scribed in, are about 1/2 mil over what they need to be. It just allows me to keep those markings in play. Alright, I think we'll pack it in for the night. It's getting a bit late, so we'll come back tomorrow with the boring facing head, and we'll finish these off. Okay, so we've made a little blue here. For some reason I put the head down and it wasn't on the right side of centre, the 4.5mm this side, it was 4.5mm that side, and I thought I was clear. I've turned it on to check it, and the tool's just caught. It's probably only about 0.2, 0.3mm. So what I'm going to do is take the chuck out, set it back up in the lathe, give that a light lick. How much I've taken off, I will add on to the thickness of the bush that's going to go on here. So we'll compensate for that way. Don't want to take too much off because my lip seal is getting fairly close to the edge here, so I just want to take the minimum amount off that. So I'll set that up and bring it back, and we'll have another go with this facing head. Alright, so I've machined this surface back, and I took exactly 0.25 of a mil off, so 1/4 mil, so it's at about 10 thou. To set this up again, I've just got some drill rod in here. I've just stoned those to get the burrs off, just to parallel up against it, and then running backwards and forwards to get it parallel again. And then I'll stick my center finder in, and we'll get to the center, and then we'll reset up and go again. So bit of a pain, but Yeah, I don't know what happened there, but anyway, it's one of those things. Just finished 12 hours at work from a 5 o'clock start, and probably a little bit tired and probably not the thing I should be doing, but anyway, better keep it moving along. All right, we'll get this back up. We'll come back when we're ready for the boring, hopefully. I'm not going to stuff it. Alright, so as a result of my little mistake, I'm only going 0.7 deep. That's cleaned up really well, that little mistake. Set up for the second one here at the moment, so we're going to go up to that 27 millimeters. So on my little ruler here, let's come up at being on 27 millimeters, and mind you, I do have 0.5 mil clearance on the bush that's going to register in there. Alright, let's see if we touch wood. Can't stuff this one up. Righto, oops, better engage our feet. Alright. Excuse my arm. And let's see how we go. Once she disengages. And done. So that's worked out very nice indeed. Right, we'll come back and do the last one, and then what we'll do is we'll set up and do our drilling and counter boring. And I might change them from an M8 to an M6, considering we've only got M6 in the main drive shaft. There's no point putting M8s in here. Matter of fact, it's going to be stronger because it's got a larger torque arm on these. So, all right, I'll move up and we'll set up for the last one. And it takes me a little bit of time to wind that back in. I'd rather wind it in by hand. I can engage the drive here and do it automatically, but for what I'm doing, I'll just pull it in by hand. Re-engage our self-act. I'll bring that down to 0.7 of a mil, just there. And we'll see how we go. Alright, just engaged in the cut now. And you'll actually see this cut peter out. Those end mills are actually ground with a very, very light taper into the centre, so that we don't drag when they're cutting. You can actually see it when we're cutting it out here. It thins out a fair bit the further out we get. I'm about to engage full cut now. And done. We've got about 1mm land on there, so I'm happy with that. It's going to well and truly give us a good bearing surface on the lip of that seal. Right, as I said, what we're going to set up with next is I'll get set up to do the drilling and counter boring for those M6 socketed cap screws. We'll keep the same centers as what we've got here, and we'll take this out. We'll put the worm well in, and then we'll do the same with that for the drill and tap to match that PCD on those. All right, I'll get set up for that. I'll try this again. Didn't have record on. We're going to go ahead and drill this nest of socket headed cap screw holes. So we're drilling and counter boring for those, and they're not evenly spaced. I've designed them around nesting around the counter bored holes for the crank pin. So I've got a coordinate system there that we're working off. So we'll set a drill through, and then we'll counter bore. Then we'll set up the worm, and we'll do the same thing on the worm wheel. All right. Right, we'll set the next set of drills up. I'll come back when we're actually counter boring those. So, and close to finishing this one off. Right, I'm just going to counter bore in for the M6 socket header cap screws. So I'm going to do this with a 10mm slot drill. So I'm going to go down 6.5mm on the depth. That puts it just a little bit below. So I'll just zero that off. Right, we'll just take it easy and we'll see how we go. Just going to feed down with a hand wheel. We'll get 6.3. I'll move that across and we'll see how that looks. That's going to be quite good. That will be fine. All right. Right, we'll position it up for the last one. So 22.5. Alright, that's everything finished bar the drilled and tapped holes for our crank pin. So I'll set up to do those now. They're M6, so I'll get my little M6 spiral taps and I'll get that set up. Alright guys, so we just started tapping this one out. And you can see those tips being ejected out. Had a bit of a snappy noise in there, I don't know what that was. Let's just hope that I haven't got... No, it's all in one piece. I thought I might have done some damage to the end of that. Alright, last one. Yeah, I got these spiral tap through Banggood. John Mills from Double Boost did a review on them, and I bought a set, and they have been fantastic. Great for these blind holes. Great for any holes, actually. Alright, we are done. I'm going to leave this in place because I know where the centre is. I'm going to set up the worm wheel, and we'll drill and tap to suit those M6 socketed cap screws to bolt that crank disc onto that onto the worm wheel. But for now, I'm going to pack it in now. It's getting late. Early day again tomorrow, so we'll be back after work, and we'll get this finished off and get it all fitted up. See you guys. Right guys, just drilling the holes to tap, drilling and tapping the holes for the mounting of the crank disc. So I've kept the centre the same, haven't moved that. I'm keeping the same coordinate system, 22.5 and 15.9 across and 15.9 from centre either way. So we're only going down about 15 mil. Right, we'll set up to tap them out M6. Righto, done. I'll deburr this, and we'll see how the two go together. Righto, let's try out some of these fitments. First one we'll try out is the seal. So that's the way the seal is going to be facing. It's in position, and that's going to slide over it. So that's sort of roughly where that seal is going to fit. Roughly. Right, so that's good. Well, you can see this come up quite well. There's only one little witness to show that I had a problem with that, and it's just the tiniest little witness mark just here. So other than that, we've got out of that well. And the other one we're going to try is how this fits up. Right, so it's a neat fit into that. This will sort of show me, I guess, how good my digi readout is. Right. cut these back because I knew they were going to be too long. That one's okay. I'll just go and give them another touch on the grinder so they fit up a bit better. Alright, we're back in a minute. Righto, take two. I guess it's probably easier to try and fit this stuff together off camera, but you sort of don't get to see the little problems as you go along. So, like I said, I'm keen to see how good these are, since we did this off the coordinate system, as to if there's any binding. These are a tight fit, well, not a tight fit, but a sliding fit in the hole, but also a fairly close tolerance fit on the head as well. Okay, well, it's screwing in there, alright. That one there, I think. Alright, so he's down. He's down. Yep. That's a winner. I won't do them up tight because I've got to undo them anyway, but no, that's spot on. So that is spot on. I'm happy with that. So that's how that mounts into onto our wheel mill. That mounts into our drive shaft. So I'm going to fill that together now. Before we do, we might just see how this is going to look with the seal in position. So I'll just put it in onto it. Right. That's better. Must be a 5/16 or something. 4th thread. All right. I'll just take the camera off. I'll head over to the housing. Well, I've sort of sat it in there. It's obviously got to be pressed all the way home, but that's sort of how it's going to look. Our crank pins bolt into whichever radius arm that we want to work to give us a slotting stroke. That one's our maximum at 33, so that gives us a 66 max, so it's over 2.5 inches. And then we come down to the smaller strokes. Alright, well I might get that mounted up onto the drive shaft, and we'll see how that looks inside the housing. Righto, so we've got that into position. That's fitted up beautifully. So having the socketed cap screw in the back there, the head for it, is an absolute godsend. You wouldn't be able to do these fasteners up, these socketed cap screws up at all without being able to lock it down with an Allen key at the other end. But it's coming together all right. I'm happy with that. Right, next job we're going to move on to, I think we'll start having a look at the 2 slideways and starting to machine those up, or putting a plan together to machine them up anyway. Alrighty, I'm happy with that progress so far. Got out of jail. Yeah, I was 4.5 millimeters the wrong side of the centre when I was machining that, and thought I was above the surface until I turned it on. But yeah, these little things catch you out. But anyway, we got out of jail on that one, and it's come up really, really nice. So we'll move on to the next operation. Alright, see you soon, guys. Alright, sometimes it's good to stop and smell the roses. Sometimes it's good to put what you've built, or what you've made up so far, start assembling it and just sort of seeing how it looks and how it feels, and if it's the way you think it should be progressing. So I bolted everything up and put the caps on. Put the rear section on. And it looks quite good. It's starting to come together. Well, at least I think it is anyway. And you can see the action that's going to be once we put this on the motor and that's cranking around. So that's going to oscillate will actuate our crank going backwards and forwards, which is going to transpose onto our slotting shaft. And yeah, that feels really smooth. A little tiny bit of backlash, but it's what we want to see. So yeah, I'm happy with this so far. It's looking the way that it should look. So as I said before, we'll start working on the slides now and getting them machined up and getting all that fitment done. So there's going to be a fair bit of work on the milling machine for a little while. And yeah, we'll get on to this next stage. I'll sleep tonight. All right, see you guys.